Hello, calculus fans! Let's try to use Euler's method with step size h equals 0.25 to estimate y of 1. So we're estimating that where y is the solution of the differential equation y prime equals x plus 2y, and our initial condition is y of 0 is equal to 0. All right, now we're using h equals 0.25, that's our step size, and f of x comma y, that's just going to be the right-hand side of our differential equation. Now y of 0 is equal to 0, so let's take a look at what our setup looks like. Now x naught is equal to 0 and y naught is equal to 0. That comes from our initial condition. x1 is 0.25, so to get to the next x value, we just add the step size. So remember that we started with step size 0.25. Now what we don't know is y of 1. We're going to be computing that. But we do know all the x values. So our setup looks like this, which means what we're looking for is this final y value, y sub 4. That's what we're going to be trying to compute. That's going to be our final answer when we get to it. All right, so the formula for Euler's method says that y1 is equal to y naught plus h times f of x naught y naught. Now remember that both x naught and y naught were equal to 0, so we just plug those in and we get y1 is equal to 0. All right, doesn't seem like we're making any progress, but we are. We get y2 is equal to y1 plus h times f of x1 y1. Now we plug x1 equals 0.25 and y1 equals 0 into this. All right, now we got y of 3 is equal to y of 2 plus h f of x2 y2. Let's see, we remember that h2 is 0.5 and y2 is what we had just computed here. Okay, plug those in and now we get 0.21875. Okay, one last one. Remember, we were going for y4. So y4 is equal to y3 plus h times f of x3 y3. Plug in our numbers. Remember, x3 was 0.75 and y3 was 0.21875. And so we get our final answer of 0.515625. What we're saying here is that y of 1 is approximately equal to 0.515625. If we could solve this differential equation and come up with an answer for the unknown function y, and we plugged in 1, the actual answer would be pretty close to 0.515625. At the moment, we don't have a way of finding a solution to a differential equation, so we have to settle for this method of approximating a solution. Okay, that's all for now.